Hi again, this is now Monday, April 20th. This is QBUS-110 again. And today we're entering the wonderful world of 12.2, section chain rule of integration. Before we do that though, I want you to know our next homework and our final homeworks come from this document here, which is labeled Worksheet Take Home Test. Well, it says Take Test. I don't know what happened to the home. Take Test Homework, Chapter 12 and 13. We're going to go away from the book and away from WebAssign. You must hand this in by the day of our review class. Now, if you want, you can hand in Chapter 12, submit Chapter 12 at the end of next week, this week, and submit Chapter 13, or you can submit the whole thing in one packet. Notice at the end, please put your answers on the answer sheet on the back. Okay, it'll make it a lot easier grading if you do that. Okay, first of all, some things about Section 12.1. The homework on here is number 1, A to L. Those are integration practice, which you're going to need to learn this. And then you'll do practical questions 2 to 7. Section 12.2, number 8, A to H. This is the chain rule of integration practice. Then you'll do 9 to 12. Omit 13A, it's a repeat of 9 for some reason. When we get into 12.3, we're going to do number 13B. It's labeled B. It's a 13 though. And you're just going to do 3 integrations, A to C. Then you're going to do 14, 16 to 19. Number 20 is going to be a bonus. Please omit number 15. It's a very difficult natural log problem, and I'm not going to get into natural logs that much for integration. And last but not least, in Chapter 12, Section 12.4, number 22 to 24, 26 to 29. These are all practical problems. And number 25 is a bonus. So you might want to write that down. I will probably send you an email with that also down so they're all on the same page. That all comes from here. Don't forget, in the end, you submit this and make sure you use the answer sheets. Okay. And this is going to count as a take-home test too. So maybe 2, because there's a lot of problems on here. So it is really imperative that you do this. As I said, there's no hard copy from the book and there's no WebAssign on here. I'm keeping us all on the same page. Okay, for today's class, we're going into Section 12.2, the chain rule of integration. And I think I should erase and put this on the top. And this way, will be a lot easier to see. Basically, example 1, integrate the integral of 3x squared. I started this the other class, but I didn't get too far, so I'm going to do it again. Now notice, there's no product rule for integration. And you cannot use the power rule that I'd have up there on the board because I have an extra appendage, an extra function of x there, 6x. So I have to do the chain rule. First, I'm going to do it in steps, and then I'm going to give you a rule, which I developed. You won't find it in the book, and I hope it makes things easier. I really don't see a real rule for this in any of the books that I've looked through. Okay, so step 1. I'm going to let you equal, oh, this is a power, I'm sorry. This is to the 5th. This is to the 5th power. Otherwise, you could just distribute this 6x and do each separately, then use the power rule. But the fifth power makes this, unless you wanted to expand this using a binomial expansion to the fifth power, you would let u equal 3x squared plus 4. Now usually u is what's inside the parentheses, which is raised to a power. Usually. Now du dx is going to equal to 6x. What I'm going to do here is I'm going to, the second step is find du dx. I'm going to cross multiply. Then I'm going to divide by dx. I'm going to divide by 6x. So dx equals du over 6x. And these are the two things that we're interested in. Okay? Now, I'm going to call this du over b, where b is either a constant or a function of the independent variable, in this case x. All right, so I'm going to substitute this in here. Here b equals 6x. So I'm going to substitute this in here. It's going to give me u to the fifth. 6x remains. I haven't done anything like that. Dx is going to be du over b, which is 6x. Notice we now got rid of the x's, which is our goal. I cannot do this because now I can use the power rule. If I couldn't get rid of the x, I can't use this procedure. So, given the power rule, oops, and given I dropped the pen on my foot.
That was a demonstration of the rule of gravity.
Yes, it's Newton's rule of close gravity equals mg. Okay, so this is going to be u to the 5 plus 1 over 5 plus 1 plus c. Notice a is 1 here, if you look at this power rule there. Okay, so let's substitute back for u, which is 3x squared. And that's going to be 6 over 6 plus c. The integration sign is gone now. Okay, and this is going to be 1/6 3x squared plus 4 plus c. We always need a constant, which we're not going to know at this particular point in time. So let me turn over my... So that's your answer. And if we had this, if this was what we had here, suppose that was dy, well then this would be y, and y equals, okay? So that would be the complete... Sometimes they just give you the integral and just want this side of it, unless it's a practical problem. So anyway, well, what were the steps? Step 1 was to let u equal 3x squared plus 4, usually what's inside the parentheses raised to a power. Take du dx, figure out what dx is. Step 3, substitute in the power rule. And step 4, solve it with a constant. And if you want to do it a different way, you can clean up things, add things, combine things, whichever way you want to do. All right, let's do another one and then use a rule that I made up. I hope it helps you. Some people don't like to do things in steps. And it's hard to remember, but if I give a rule, I can put it right down on the sheet. So let's take another example. In the example here, I don't want to use this one, it's too simple. Here we go. So example 2, is the integral of x third 5x fourth plus 1 to the fourth dx. And I want to find this. Find the value, well, find the function. Okay, well, notice once again, I have an appendage here. So let's give a rule. Well, let's say this is the Dr. M chain rule of integration. Okay, so let's say we're given this. Y equals the integral. Let me get my formula down here. I'll be right with you. I want to put it in the way I did it. A u to the n. That's a nice sound. A function of x dx. I want to integrate that. So let's say this is dy and that's an integral. So y is going to be equal to a, didn't know I was from Canada, right? A, okay, f of x times du over b. So we have to define these. So let's look in this problem here. A is what's in front of the parentheses. So for this problem, a equals 1. U is going to equal to what's inside the binomial, 5x fourth plus 1. I have to take du dx, 20x third, sorry. Now let me solve for dx. Dx is going to be du over 20x third. So this is du over b, where b is 20x third. Okay, notice because I did b here, I really don't have to solve for dx anymore. All I need is to say, to do du dx and set this equal to b, but we'll do that for the next problem.
Yeah, 2 minutes.
Okay, 2 minutes, and once again, I don't put the eraser where I should put it.
I thought you had a spot all picked out.
I did, but I don't put it there. Yeah, it only works out if I put it there.
The fatal flaw, the one bug.
And n equal here is 4. So, so let's put this in here. Y equals a is 1. U is 5x squared plus 1. 5x fourth plus 1. N is 4. 4 plus 1 over 4 plus 1. F of x is what? Well, f of x is given as x third. I forgot to define that here. F of x equals x third in this case. So we're going to have x third, which stays, and du over b, du over 20 x third. Okay, now notice, is that 20x third? Yes, it is.
Yeah.
Okay, so notice now the x thirds cancel. So now what I have, I just have an integral in, well, what I forgot to do is what?
The integration sign. You got 10 seconds, by the way.
We'll come back in a minute. No,